So most of the time in chemistry, we have more than one reactant that we need to completely use up the other reactant. So sometimes we have too much or too little. It's difficult to figure that out. So that reactant is said to be in excess. Again, it's like the whole bread and bologna thing. If I use up all my bologna, my bread is in excess. If I did this chemically wise, I could say that if I have more calcium, or all of my let's say that all of my calcium reacts, then I would have extra oxygen left over. It's the same concept. The other reactant limits how much product we get. Once it runs out, the reaction stops. And this is called the limiting reactant. So the chemical reaction will go until one of the two reactants runs out. Once that runs out, the reaction stops. It's plain and simple. All right, so that's what I want you to understand. The reactant where there's something left over is said to be in excess, and the one that runs out is said to be what is limiting. So when we go through and do these problems, there's a little bit of a difference here. To find the correct answer, we have to try all the reactants. So instead of one given, you're actually going to have two or maybe three. And then we have to calculate how much product we get. The lower the amount of product that's produced is the correct answer. So you're going to have to do two stoichiometry problems here. Whichever one is less is the right answer. The reactant that makes the least amount of product is the limiting reactant. The one that is more is in excess. All right? So just a couple words of advice. Make sure to pick a product. You can't compare to see which is greater and which is lower unless the product is the same. This all has good meaning, but we really need to jump in and see how this works. So just again, to quick review, we're talking about limiting reactant here. You're going to have two numbers for your reactants. You're going to have to convert both of those to product. Whichever one produces the lower amount is the limiting reactant, and the lower amount will always be the correct answer. So keep that in mind as you do these problems. Let's go through a couple. 10 grams of aluminum reacts with 35 grams of chlorine gas to produce aluminum chloride. Which reactant is limiting, which is in excess, and how much product is produced? So let's jump right in. The same rules. This is the almost exact same stuff we've been doing, guys. There's only just one little difference. So let's go through it together. First step, balanced chemical equation, right? Aluminum reacts with chlorine to make aluminum chloride. Don't forget your charges, guys. All right? Balance your equation. I know, I make it look easy. I'm just trying to get to the good part. You should already know how to do this, okay? Now, it's a limiting reactant problem, and I know that. I know it's a limiting reactant because I am given two numbers here. I have two givens, don't I, instead of just one. I have 10 grams of aluminum and 35 grams of chlorine. There are two givens here, not just one. So I know this is limiting reactant. It also asks which reactant is limiting. So the real question here, I've got a couple things I need to do. The questions are, which reactant is limiting, which is in excess, and how much product is produced. So we need to figure out how much product is going to be made. That way we can tell limiting and excess. Let's start with aluminum. "10 grams of aluminum. The process is the same. Grams on the bottom. I convert grams into moles. Find that information on your periodic table. Moles of aluminum. It's asking for how much product is produced. My product is AlCl3. Again, coefficients of the balanced chemical equation. Follow the rules. Again, follow those rules of dimensional analysis we've talked about. for so long. This is what all that boiled up to, guys. And that's why it's so important that you know how to do this well. Molar mass, where do we find it? That's right, periodic table. I'm assuming you guys all said that. Hopefully not all at the same time. All right, let's convert to product. 10 times 2 times 133.33 divided by 26. I gotta do it over again, my stupid calculator. I'm actually quite amazed that my cat has not come in and barged in on the conversation here. Hey, here we go. Product. Okay, significant figures. We got 3, so we need 3 in our answer. So it's 49.4 AlCl3. Now, the big question, are we done? And the answer is no. We started with 10 grams. Now we have to start the same process again, but with grams of chlorine. This is where this gets different. You've got to do this twice, because whichever one is lower is the right answer. So let's go through it one step at a time. Grams of chlorine, same rules, same steps. All right, I'm not going to go through all of it, but I want to show you how this process works. I shouldn't have to explain this over and over again, but again, moles of Cl2, what do I want? AlCl3. Only way you can convert is through moles. Moles down here. I can finally go to grams. What's nice is that some of this stuff is the same. So you don't have to go recalculating a whole lot of things. Like the molar mass there at the end, it's the same. All right, do the same thing you did before. Do the math. 35 times 2 times 133.33 divided by 70.9 times 3. 43.9 grams of AlCl3. Okay, so again, we need to figure out which answer is correct. Whichever one is less is our right answer. So, 49.4, 43.9, the answer, that is your correct answer. If that is our correct answer, then we say that chlorine is limiting, because that's what produces the lower amount of product. Chlorine is going to be gone before the aluminum will. So that's limiting. Therefore, aluminum, we say, is in excess. Okay? So we solved all of 3 parts of the problem. We determined how much product is produced, what is limiting, and what is in excess. So just recap, solve for both. You're given 2 givens in the problem. Convert both to the amount of product that you want. Whichever one is lower is your right answer. Whichever reactant produces the lower amount is the limiting reactant, and whichever one isn't is in excess. So again, we get 49.4 grams of aluminum chloride from the given amount of aluminum, but only 43.9 grams from the given amount of chlorine. Therefore, chlorine limits the reaction. Once the 35 grams of chlorine is used up, the reaction stops. Let's do one more. 15 grams of potassium reacts with 15 grams of iodine. Calculate which reactant is limiting and how much product is made. Let's do it. Let's get to it, guys. All right. How about orange this time? I like it. 15 grams of potassium reacts with 15 grams of iodine. I ain't really talking through this much. You guys should know how to do this. This is the same thing. I have two givens, don't I? I am given 15 grams of potassium and 15 grams of iodine. The question, two things. Which reactant is limiting? How much product am I going to make? Let's do it. Start with potassium. And you can start off however you want. It's your problem. But you have to follow the same steps. Gram to mole. My periodic table, I think it's like 39 something, maybe. Oh, 39.09 or 39.1. I want product. My product is Ki. Coefficients of the balanced chemical equation, 2 to 2. Finally, I can go to grams of Ki. Let's figure out what that is. 126.9 plus potassium 166. Again, 1 mole. Remember, anytime you go mole to gram, gram to mole, it's always 1 mole. The only time you ever use other numbers in mole is if you got the mole ratio. Let's solve 15 times 2 times 166. Divided by 39.1 times 2. 63.7 grams of Ki. Are we done? No, because we got to start off with 15 grams of iodine, don't we? Yeah, I know it's a lot more work, but this is all your test is going to be over. It's doing stuff like this. Molar mass of iodine, periodic table. Just keep chugging along. Again, I want to get it to product. So I need moles of Ki. Coefficients of the balanced chemical equation, 1 to 2. Grams of Ki. All right, let's solve, guys. 15 times 2 times 166. Divide that by 253.8. Okay. Those are my two answers. Which one's correct? It's whichever one is lower. So this is your right answer. Which one limits the reaction is whichever one produces the lower amount. So we say iodine, whoa, crazy line there, is limiting. If I asked for which one was in excess, you'd tell me it's this one. All right? So again, convert both problems to your product. Determine which one is less. That's your correct answer. The reactant that produced the lower amount of product is limiting. The other reactant is in excess. That's all there is to this. I want you to finish up and work on your next homework assignment, which I believe is homework number 20. Homework number 28, I believe. Work on that. Finish it up. And that's it, guys. I'm going to post some homework problems as well for you guys if you seem to be struggling a little bit. But that's all there is to this. Plug and chug, guys. Best of luck to you. We'll see you on Monday or Tuesday of next week.